Nice. 403 to the HAZ. What has happened, Hazelton? We are talking about linear equations, and I think this is the last video I'm going to do today. Get some more lights going here. Okay, so we're talking about the equations that represent linear graphs, okay? Linear equations. And we have there's different ways of looking at essentially the same equation, okay? So let's take a look at those. The first that we learned was, what color do you guys want me to do these in? I will do them in green. I'm gonna rotate. So the first we had was slope intercept form. Slope intercept form, okay? And just like the name tells us, slope-intercept form allows us to identify what the slope, m, and the y-intercept, b, are, just by looking at it. Because slope-intercept form looks like this, and looking at it, basically, when x is 0, that's where we cross the y-axis, right? And if you just make x 0, then y is equal to the intercept. So that's why b tells us instantly, this is where I cross the y-axis, and m tells you instantly, this is how steep I am. And if m is negative, it means it's actually going down from left to right. From negative x to positive x, it's actually a down slope. So it's deteriorating. We're getting smaller in respect to the y's. So that's slope-intercept form. And then the next one we learned was, I'm going to do this one in red, was slope-point form. Okay, slope-point form allows just that. That's to identify the slope and a point on the line. But from this, we can't instantly know what the y-intercept is. And slope-intercept form is y minus y1 is equal to m times x minus x1. Okay, and so we can identify the slope is still m, it's still going to be the number in front of the bracket, in front of the x minus x1. And then x1, y1 will be a point on the line. And it will have been given to us as a coordinate, like 3, 6. Okay? So if I was given a coordinate of 3, 6, I can just put in 3 for x1, 6 for y1. And then obviously, if they were negative here, I would have to make them y minus negative 6. Or whatever. The sign is basically opposite what we see there, but look at the video on slope-point form to understand that property. If we have a point on the slope, we can put them in, and then we can solve for y to get to this form, and then from there we would know the y-intercept. Okay? So now we're learning, we're learning a couple more. Basically, we're learning how different ways that we can represent slope-intercept form. It's actually not so bad. So the first way is general form. Okay? General form. The general form is very easy. Basically, we just move everything to one side and make it equal to 0. So if I was to put this into general form, it would just be y minus mx minus b is equal to 0, okay? I would just move everything over to one side, and that's what it would look like. Now, in practice, this is kind of the form that we use to represent it. It's some number a times x plus some number b times y plus some constant c is equal to 0. Ax would be this term, by would be this term, c would be this term. So we'll kind of play with this and we'll see what it is. But imagine they give you something in general form. They say, okay, we have an equation of a line. It is 2x plus 4y is equal to 8. We'll say 4x plus 2y is equal to 8. Or sorry, minus 8 is equal to 0. Now in this case, a is equal to 4, b is equal to 2, and then c is equal to negative 8. If I want to convert this into slope-intercept form, all I have to do is solve for y. So what I do is, well, I'm going to leave 2y on this side alone. I'm going to move the 8 over by adding 8 to each side. And I'm going to subtract the 4x from this side and move it to this side. And then I have 2y is equal to 8 minus 4x. And then if I divide everything by 2, I get y is equal to 4 minus 2x, which I could rewrite as y is equal to negative 2x plus 4. Remember, just because the 4 shows up first doesn't mean it's my m. My m is always connected to my x. And so in this case, my slope is negative 2, and now I can see that my intercept is 4. And I got that just by playing around with the general form. So general form, very important. We see it all through high school math and afterwards. And then general form is very closely related to standard form. The only difference between standard form and general form is standard form, as they call it in the textbook. Standard form, let's see how they properly write it, the syntax in the textbook. They say standard form looks like, where the heck am I? Embarrassing. Okay, so standard form is, if I took, it would be basically ax, it's very similar. Basically the variables are on one side of the equal sign, so ax plus by is on one side, but then we move the constant. So then if I was to write this in standard form, it would be negative c. But you can just write is equal to some number c, where this c and this c are not exactly the same. Okay, I'll use a different variable, is equal to d. Okay, so all we do is we move the constant to the other side by subtracting it. I just called it a different number there, okay? So our variables are on one side of the equal sign in standard form, and our constant is on the other. In general form, we move it all over and make it equal to 0. Okay, that is basically linear equations in a nutshell. And we know how to work with this. We know how to use this to solve and to get into this form, right? And then all we're going to do is we're going to learn how to jump between these two or these three, and how to identify if we're in general form, if we're in standard form, or if we're in slope-intercept form. So the hardest stuff is behind us. So I'm on page 384 now of the textbook, and they are going to start asking us, well, they start giving us problems, right? So they're going to ask us, what form are we in? So the first one they give us is, we've got an equation, it's 8x minus 3y is equal to 52. And they say, is this in standard form or general form or slope-intercept form? And you look here and you're like, that looks like it is, I've got my variables on one side, my constant on the other, that's standard form. And then I have 9x plus 4y plus 21 is equal to 0. What form I am in here? Am I in here? Am I in here? Am I in here? General form. It's all equal to 0. Y is equal to 4x plus 7. What form am I in here? Slope-intercept form. Very good. And finally, just to round this one out, I've got y minus 3 is equal to 5x plus 7. What form am I in here? Slope point form. And what point do I have on this graph? If that's negative 3, then it's a positive x, and if that's positive 7, then it's a negative 7. Okay? Very good. So, if I had a problem like, say they gave us 4x plus 3y is equal to 36, and they say write this in general form. How would you turn this into general form? Well, first off, you can see it's in standard form. So to make it general form, I just have to subtract 36 from each side to make it all equal to 0, because that's what general form is. There, I'm in general form. Easy. What if I had one that was in slope-intercept form? Y is equal to 5x minus 1. And they said turn this into general form. Well, how would I do that? I have options. I could either move all of this over to this side and make this side 0, or I could move the y over here and make this side 0. Moving the y over looks like it's easier to me, because that's only one thing I have to move over. So I have 0 is equal to 5x, and I can move the y right here, minus y, minus 1. Or I could have left it like that. So 5x minus y minus 1 is equal to 0, or I could have written negative y plus 5x minus 1 is equal to 0. It doesn't matter what order I put those in. That's that. Okay, not so bad, hey? So what if I had a problem like this? And I've already done one like this, so I don't think there's much more I'm going to explain in this video. So if I had 4x plus 3y minus 24 is equal to 0, that's clearly general form. It's equal to 0. And they say, what is this in slope-intercept form? Well, slope-intercept form means I have to isolate my 1y, so I'm going to start doing that. First thing I'm going to, I have positive 3y here, so first I'm going to get rid of this 24 by adding it on both sides. So I have 4x plus 3y is equal to positive 24, because I did the opposite of minus. Now I'm going to move the 4x's over. The opposite of adding 4x to the 3y here is subtracting it, so that's what I do. And now I have 3y is equal to 24 minus 4x. And now all I have to do is divide everything by 3 to get y alone. And I get y is equal to 24 divided by 3 is 8 minus 4 over 3x. And then there's the equation of my line. My slope is not 8. My slope is negative 4/3, because slope is always married to the x. It's always beside the x, multiplying the x. So my slope is negative 4/3, and my y-intercept is 8 in this one. My b is 8, okay? So we have to be cognizant of, it doesn't matter what order it is, you have to be able to identify what is what. Go forth and flourish, my babies.